All right, now I got interrupted by that camera again. It's getting me kind of upset, but it's okay. So I will move on. I won't throw anything at the camera. Parallel, voltage, same side by side. Resistance, as you add, they divide. Current, the path has to be picked. Let's get done with this song real quick. Bah, 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 bah. Volts, ohms, and amps, and you remember the rest. All right. You must be careful with volts, ohms, and amps. With the voltage to jolt, the resistance to gulp, the current begins to flow. So you got to be careful. Voltmeters. You'd only need one voltmeter to measure the total because it's all the same. And voltmeters are going to be connected in parallel in high resistance. See, because you want to measure the voltage in parallel because it's the same in parallel, so you're getting the same measurement. And it's also, you don't want your electrons to get sidetracked. That's bad. Electrons going down the bad side of town, not good. Alrighty, now if you look at number 59, ammeter in series and low resistance, voltmeter in parallel and high resistance. Current in equals current out. You'll see some examples of that. I'll give you one quick one right here. So this is 10 amps. This is 3 amps. Say this is going this way, this is going this way, and the question is, how much would go through the ammeter? Well, you pick a point where they intersect. 3 amps in, 10 amps out, you have to have 7 more amps in. So it would read 7 amps, and particularly that would go that direction. That type of question, you'll see some of those. Electrical energy is measured in joules, and you've got some equations like W equals PT, and since power is VI, it's going to be VIT, and then I squared RT, and then what is the last one? Oh, I'm so forgetful. V squared T over R. And then power, watts and watts of power, VI, or you've got your, you can read it from the reference tables. You've got the other ones are I squared R, I'll put them on, and V squared over R. Very good. So looking back, last thing for electricity we need to do are the graphs. And a couple graphs. I versus V. What do you need to do for graphs? You need to find an equation first. You need to set the two things from the graph on opposite sides of the equal sign if they're not already. And then you need to compare using some rules that we need to review in just a second here. Because of our Ohm's law circle, V equals I times R, they're both opposite sides directly related. If you increase the potential difference, you're going to get more current flowing because you're going to get them a little push. And then VI, it's going to be that same one, just flip-a-roonied. And then resistance versus temperature. This one you pretty much just need to know. This goes back to the cold resistor and cold conductor is low resistance. Hotter is high resistance, like this. Okay, and then resistance versus current. Now if you think about that, R equals V divided by I. Right on the reference tables, they're indirectly related, like that. And then resistance versus area. I'll put that down here. Resistance versus area, R rho L over A is the equation, and they're both indirectly related to each other. And that is the end of electricity. Thank you.